Welcome back to the Data Professor YouTube channel. My name is Tanin Nanta Senamad, and I'm an Associate Professor of Bioinformatics. On this YouTube channel, we do data science concepts and practical tutorials. Okay, so a couple of days ago, I released a video on how you can develop a simple web application in Python using the Streamlit library. And so in this video, we're going to incorporate an additional feature, which is machine learning capability into the web application. And so without further ado, let's get started. So the web application that we're going to build today is called the Simple Iris Flower Prediction app. And so the app will do as it says. It will predict the iris flower type given the 4 input parameters. Okay, so let's have a look. What does the web application looks like? So the first thing that you want to do is head over to your command prompt. So if you're on a Windows, you want to click on the search icon, type in CMD. If you have a Mac or a Linux, you want to open up your terminal. And because I have everything in my environment, I will activate it by conda activate DP. Then move to the desktop. And then I'm going to run the web server by typing in Streamlit run. And then the name of the file. Enter. And so the file to this web application will be included in the video description. So you want to check that out in order to follow along with this tutorial. So notice here that it's going to spawn up a website for you on your local computer. And so the URL here is localhost : and then followed by the port number, which is 8501 on my computer. Okay, so this is the web application, and the first line here is the header of the web app. Let's have a look. What does this looks like? Let me expand it a bit. Okay, so as you can see here, the web application is comprised of 2 components. The first component is the main panel here, shown to the right. And the second component is shown to the left, which is the sidebar panel. And so the sidebar panel here, as it is called here, user input parameters. It will accept the input parameters comprising of the 4 features that we will be using to make the prediction. And under the hood, the prediction will be made using the random forest classifier. And to the right here, upon selecting your user input values for the 4 parameters here, and so you will see that the default values are provided in the slider bar here. So we can see that simple length has a default of 5.4. And if we modify the number here to the right in the table, we're going to see that the number also modifies and updates as well. Same thing if I modify the other variables, you will see that the numbers inside the table here will be updated. And correspondingly, the prediction probability and the prediction will also be updated as well. And so the model will be applied to make the prediction based on your input parameters. So if you change the input parameters, the model will be used to make the prediction once again. As shown here, if I modify it, then the predictions will be created. Okay, pretty neat. And so let's have a look at the corresponding code which makes all of this possible. So let's head over back to the code. And so let me give you a line-by-line breakdown of the functionality of the code here. Okay, so I noticed that we didn't use NumPy, so we're gonna delete that. Okay, so now it's well under 50 lines of code. 49 now. All right, now it's 49. So in the first 4 lines, we're going to import the library that we're going to use in this app. And lines number 6 through 10 will be a simple markdown text telling us the name of the flower. So let me open it side by side with the web application. So the header here is right here. Okay, and the text here, this app predicts the iris flower type, is right here. And so I can make it bold, save it. And it doesn't change, so I have to say always rerun. So it will be updated automatically. Alright, so you see that it's bold now. And so st.sidebar.header on line number 12 will be the name of the header of the sidebar panel right here. User input parameters. And so notice that if I take out the sidebar, it will move to the right, to the main panel. Okay, so having it in the sidebar panel will be possible if we use the .sidebar. Okay, so let's save it and it'll move back to the sidebar. Okay. And lines number 14 through 24 will be a custom function used to accept all of the 4 input parameters from the sidebar, and it will create a pandas data frame. And the input parameters will be obtained from this sidebar as shown right here to the left hand side. And the text here will represent the name shown here. So actually, I could modify the name as such. I can make it capital and then add a space and save it. And notice that the name also updates. So why don't I do that for the other one as well? Otherwise, it might be confusing whether it is a variable name or not. So this could be any text that you want. All right, and so the name is updated here. And so the first value here represents the minimum value, and it is 4.3. And the second number here represents the maximum value, which is 7.9. And the third value represents the current selected value, or the default value, which is 5.4. So here, 4.3, 7.9, and 5.4. And so if you want to change the default value to something else like 5.8, and then it would be changed to 5.8. Okay, let me change it back to 5.4. All right, so here we're going to use the custom function that we built above, user input features, and then we're going to assign it into the df variable, and this will be on line number 26. Okay, and lines number 28 and 29 will be right here, user input parameters. So you can see that in just 2 lines of code, we could have the section header name and the corresponding table below. So it's just a simple printout of the data frame. And lines number 31 will be essentially just loading in the iris dataset. Line number 32 will assign the iris.data into the x variable. And the iris.data are essentially the 4 features comprising of the sepal length, sepal width, petal length, petal width. And this will be used as the x variable, and it will later be used as the input argument. And the y variable here will be using the iris.target. And so they are the class index number of 0, 1, 2. And line number 35, we will be creating a classifier variable comprising of the random forest classifier. And line number 36, we're going to apply the classifier to build a training model using as input argument the x and the y data matrices. Okay, and in line number 38, we'll make the prediction. 39 will give you the prediction probability. Lines number 41 and 42 will be just a simple printout of the class label and their corresponding index number. Line number 44, 45 will give you the prediction. And so the prediction here is the class label of being either Setosa, versicolor, or virginica. Line number 48 and 49 will give you the prediction probability. And so the prediction probability will tell you what is the probability of being in one of the 3 classes. So here, it is predicted to be iris Setosa. So what's the probability of it being a Setosa? So the probability is 100%. So if we change the input parameters a bit, and we're going to see that now it is still predicted to be Setosa, but the probability of being Setosa is slightly reduced to 90%. And there is a 7% chance of it being a iris versicolor and a 3% chance of it being a iris virginica. Okay, and there you have it, a simple iris flower prediction app. And if you have watched this far in the video, kudos to you. You're helping to support this channel, and let's help beat the YouTube algorithm. And please like, subscribe, and hit on the notification bell in order to be notified of the next video. And as always, the best way to learn data science is to do data science. And please enjoy the journey. Thank you for watching. Please like, subscribe, and share, and I'll see you in the next one. But in the meantime, please check out these videos.